Finishing out this sample test, question 11 asks me to find the point of inflection in the graph. In order to find the point of inflection, I need to find the second derivative. So I start by taking the first derivative, f prime of x. That gives me 3x squared minus 18x plus 5. When I take the second derivative, that gives me 6x minus 18. If I factor that, the 6 comes out, and I'm left with x minus 3. That 3 is the only thing that makes this 0, and that is going to be my candidate for point of inflection. But before I move on with that, I'm going to make a number line just to make sure it switches concavity at that point. Otherwise, it would not count as a point of inflection. So on my number line, I have 3. If I try something less than 3, say 0, 0 minus 3 is negative, times a positive 6 is all negative. If I try something bigger than 3, say 5, 5 minus 3 is 2, which is positive, times 6 gives me a positive 12, so this whole section is positive. Now I can see that yes, I did change from negative to positive at 3, so 3 is a point of inflection. But when Cengage asks you for a point of inflection, they want an xy point, not just the x value. So I'm going to plug this 3 back into the original equation. F of 3 is going to become 3 cubed minus 9 times 3 squared plus 5 times 3 minus 2. 3 cubed is 27. Negative 9 times 3 squared is negative 81. 5 times 3 is 15. And then minus 2. When I do this, 27 minus 81 gives me negative 54. Negative 54 minus 2 gives me a negative 56. Plus 15 gives me a negative 41. Let me just double check that. 15 plus 27 is 42, minus 2 is 40. Negative 81, 40 is negative 41. So I can go back to my point of inflection and say that x equals 3, y equals negative 41. Since I already have my number line done, it's really easy to translate this into my concavity. I'm concave up, starting at 3, going to infinity. I'm concave down, starting at negative infinity, going up to 3. Final question on here is to find the limit, if it exists. So these are limits to infinity, where really what I care about in these fractional forms is where's the highest power of x. In the first one, the highest power of x on top is negative 9x. The highest power of x on bottom is 4x cubed. Since the bottom is bigger than the top, the limit to infinity equals 0. For the second one, the top highest power of x is negative 9x. The bottom highest power of x is positive 4x. Since these are the same power of x, the x's go away, and I'm left with a fraction of the coefficients, negative 9/4. In the final one, the highest power of x on top is negative 9x squared. On bottom, it's 4x. Since the top is bigger than the bottom, my answer is infinity.